Hi everyone, I am R. Kumar, Assistant Professor, Department of Computer Science and Engineering, St. Martin's Engineering College. Today let's talk about RSA algorithm. So what is RSA algorithm? First we have to think about RSA. Before I enter the topic, first all should understand what is RSA algorithm, the purpose we need to study the RSA algorithm. First, I start with the cryptography. So at today scenario, we all are think about the security issues. So the security issues is huge in front of us. How to you are escape from the security issues? What kind of the data we need to access and how do we ensure the security? So these are the things nowadays the big question mark and $1,000,000 question in front of us. So in this part, I am going to explain RSA algorithm. What is RSA algorithm? So let me go one by one. So here I am going to start RSA algorithm. First, we have to see the introduction part. So these are the topics I am going to explain one by one. The first one, what is the RSA algorithm and how it works. Second one, introduction RSA algorithm in cryptography. Third one, say examples of asymmetric cryptography, then RSA algorithm, key components. Next one, example of RSA algorithm, idea behind RSA algorithm, advantages, disadvantages, applications of RSA algorithm. If vulnerable to quantum computing, we can ensure the security of RSA algorithm. So this is an important one. If vulnerable happen, how do we avoid? So what you can enhance in security in RSA algorithm. So these are the topics we are going to discuss one by one. The first thing is what is RSA algorithm? So in this algorithm is one of the asymmetric cryptography technique. Which one is the public key and private key. Using them we can protect the data. So this is a process of the RSA algorithm. Whereas is how this RSA algorithm built. That's the important one for us. So this RSA algorithm, why it is popular? Because of the fully mathematical components. So this mathematical complexity it contains. So particularly what it does, the factoring large integers. So this is an important one. Using them, we can make it extremely challenging process for the unauthorized entities to decipher the encrypted information. So this is an important one. So basics about the RSA algorithm. How it works, why I use this mathematical complexity, the factorizing is the important one. The factorizing in the sense, if I give the small numbers, we can easily factorize. But when we give the large numbers, it means 1024 bits and 2000 bits. When you go beyond the 1024 bits, your information to be secured. So that is the important for us. That is the factoring the large integers. Next one, extremely challenging. The extremely challenging in the sense any intruders can easily understand your information is vulnerable, it's a leakaging and other parties can easily access. So avoid that cases, we should increase the challenges. So how do you increase the challenges? When you are using the large prime numbers, your information fully secured. So one more thing, you should understand the cryptography normally called as one-to-one function. Why one-to-one function? The one is a sender, another one is a receiver. The both should communicate each other. Any intruder can understand their communication, that information is not secure. So that's why the cryptography is a one-to-one. From the cryptography, what we need to understand about this process, and in this cryptography is one of the algorithm is the RSA algorithm. Nowadays the RSA algorithm so popular one. So that's why we need to understand the rest of the matters is a one by one. Next we are going to see so introduction about the RSA algorithm in cryptography. So another name we call it as in crypto system is a collectively elements called crypto system. So in which what we need to understand RSA algorithm, who is introduced this system? There are the three peoples. The three people name called as Rivest, Samir, Adelman. The three people name suited as a RSA. The initial letter is called as RSA algorithm. This algorithm is widely used in area. How this widely used? So this method is called as the public key cryptography. It employs the two pair of the keys. It contains the two pair of the keys. One is the public key, another one is the private key. Using them, we can secure the information and protect your data sets. So these are the process. So using them, we can strengthen the RSA algorithm. How we can strengthen the RSA algorithm? So using the two large prime numbers. So these large prime numbers are making the unauthorized access the highly impractical. Okay, it's not an easy one. So when I use the huge numbers or the above 1024 bits or 2000 bits, if I go that kind of the numbers, if I choose, it's a really complicated one. It is not easy to access the message by the intruders. So next one, you are developed, this was developed in 1977. The three people developed, already I told you. These algorithms is a cornerstone of the modern cryptography system. So this one is a modern cryptography system. Modern arithmetic operations used. So collectively called as this one of the system. So next what we have to discuss is some example of the asymmetric cryptography. So before we go for that RSA algorithm, first we understand that asymmetric, because RSA algorithm is the one of the asymmetric cryptography. Why? Because two different key used. We need to understand the difference between the symmetric and asymmetric. Symmetric, the both end, sender and receiver using the same key. But in RSA algorithm is one of the asymmetric cryptography in which we have to use the two different keys. One is the public key for the sender and private key for the receiver. Sender when send the message using the public key, when receiver receive the message from the sender, decrypt using private key. That is the difference. So in which what we have to understand, I have taken one small example for your understanding. So if a sender wishes to transmit a message securely to receiver B, here the two person interacting, one is the sender A, another one is a receiver B. Sender when send the message, okay, please you listen. Yes, when sender send the message, sender A encodes the message using receiver B's public key. Is here noted very important one, the public key, B's public key. Next, receiver B, the B receiver decodes the message using their private key. So here the two keys are playing the vital role. The first one, center A, encodes. Encodes means that encrypted your message, original text encrypted here using the receiver's B's public key. So please you carefully you note down, this is a public key. Next, receiver when they receive the message from the sender, that is the decodes, which is called as a decryption. So that message using their private keys. We have some private keys, using them we can easily open the original text. Next, RSA algorithm key components. What are the key components? It encompasses three key components. One is the key generation, another one is encryption and decryption. So I have to show that key components here. So here the key components. The before we understand the key components, what purpose we need to build, what it has to be included. So here the aims based on the factorization. The factorization is a complicated one, already I told you. So here the large numbers, we have to choose the large numbers for the factorization. And one more thing, here use RSA algorithm, modular arithmetic for encrypting and decrypting the data. So when we have the two, the major things, next we have to generate any secure messages. So the again I tell you that there are the two process
in this RSA algorithm. One is the factorization of the large numbers. The second one is the modular arithmetic for encrypting and decrypting the process. Modular arithmetic. What you think about what is modular arithmetic? The modular arithmetic, we do the multiple calculations, modulus and multiplicative inverse. So these kind of the calculations and Euler-Torsion methods we are coming to apply. So these are the modular arithmetic functions. Using them, your message will be secured one. So next there are the three components. Key generation. In this key generation, we have to generate the public key and private key. Next one, encryption. What you have to encrypt? Center. Okay, the two people have to interact each other. One is the center. Center encrypts the data. Which key we have to use? Public key. So after using the public key, you get ciphertext. That is the important one. In decryption, decrypting a ciphertext. Next, we have to do the ciphertext using private key. Finally, what we have to get? To get the original text. This process called as the inverse process. That is called multiplicative inverse. So next, we have to see that uh, the key generation. How we generate the key? One by one, I have to explain. What is key generation? We have some steps. One by one, I will explain detailedly. The first step, we have to choose two large prime numbers. Already I told you what purpose. We have to choose the large prime numbers. When we use the smallest number, okay, we can easily access any intruders or unauthorized persons can access your information. So that is an important one. These prime numbers should be kept secret. Okay, don't share with others. So that's why here mentioned secret. Next, calculate the product of the prime numbers. First, we have to get the two prime numbers. P represents one prime number and Q represents another prime number. The two largest prime number we have to take. After you are collected the prime numbers, next we have to make the calculation of the product of two largest prime numbers. After that calculation, that value stored in A. So that is called the product of the prime numbers. The product of the prime numbers is the public as well as the private key. That's why here mentioned the product of the public key as well as the private key, because using them only, the product of the prime number only, we can generate the public key and private key. So that's why he has said this information. Next, very important one, calculate Euler-Torsion function. What is Euler-Torsion function? That is very important one. So here we have to calculate the Euler-Torsion function. It is represents pi of n. The pi of n, the p minus 1, q minus 1. Already we know the value of the p and q. The p and q is the largest prime numbers. Already we have chosen. So the largest prime number, how do we calculate the Euler-Torsion function? The pi of n, p minus 1, q minus 1. After you are calculating, one values comes, that value stored in this pi of n. So this is a process actually. So next we have to go for that, find that E value. So choose the encryption is the exponent, E actually the exponent. Later I explain how you calculate that E value. Next is such that, so next we have to look at this one, is very important one, 1 less than E and pi of n. What did understand? So here I given that one equation, that equation is a 1 less than E. Why? So if the any value the greater than as a 1, we could not process. It means what? We could not process the value. So that's why this equation is important, 1 less than E and less than pi of n. So that your value, E value should be less than pi of n and greater than 1. So this is a procedure, this is a condition also. So next we have to calculate the GCD. GCD is what? So GCD is our greatest common divisor. Why we need to calculate this GCD here? So because after you are find out the GCD only, whether the value is equal to 1 or not, we need to determine. Then only we can process. So GCD when equal to 1, okay, the E should be co-prime with pi of n. The pi of n is the one of the co-prime. So next we have to calculate the decryption. The decryption exponent d value is given here. So how do we calculate? When you multiply d and e, already we have assigned e value, d value. Oh, simply we can understand what is e and what is d. E is a public key, d is a private key. This is a simple explanation. So if understand the terms of this two, one, furtherly we can understand. D, when you multiply d, the now initially when your two the hyphen given, that is called as equal. Here this one is the concurrence. The concurrence is equal to 1. So mod pi of n, mod value already we know that mod pi of n value first you have calculated. So use that. So this value when matching, finally we can find the d. D is a modular multiplicative inverse. Why which is called as a modular multiplicative inverse? So when we take the inverse only, the receiver can extract the original message. If not done, we could not retrieve the original message, because the initially your message is decrypted, encrypted, then decrypting using private key. So this is a process. The next we have to go encryption. So encryption we have a equation. So this is an encryption process. M denotes message. Another name call it as plain text. So this your message is first converted to numerical representation using ASCII value. ASCII value we well known. So and other encoding system also there. Other than UTF, some other encoding system also there apart from the ASCII. So now use the public key. So public key, how do you represent? N comma E. N is what? Product of the prime numbers. E is what? It's a public key. So to encrypt the message and get the ciphertext using the formula. Which formula we have to use? So see that formula I will explain. C stands for ciphertext, M stands for plain text, that is called original message, and exponent value E. The E stands for encryption. And next modulus, another name called as modulus N. Here what we need to understand from the variables, here C denotes is the ciphertext, already I told you, and E and N part of the public key. Without these two elements we could not generate the public key, so it's a very important one. So next we have to go the decryption process. So here the decryption process there. So decryption process, already we converted the ciphertext. So ciphertext C denotes, then private key, the private key to argument given. So what are that parameter? N, D, argument or parameter. So parallelly we can say the name. Okay, different terms we can be used. N. N already I told you. What is N? N is a product of the prime numbers. D stands for the decryption process. So these are the functions in which finally we have to convert original data using the formula. What formula? So here M equal C exponents D mod N. So here that M stands for the plain text or another name message. C stands for ciphertext. D stands for the decryption value, and modulus N product of the prime numbers. We know very well. So this explanation is given. Next we have to go example. Uh, Through this example, next I will explain the part very clearly. So now I am going to solve the problem. Next we have to go the example. So this example I am explain. So first we need to understand that RSA algorithm sender and receiver. So using the information, so this sender and receiver how securely communicate the data. So here I have given an example. See this. So this example given here. How do we solve this example? So here I have taken the smallest prime numbers for your understanding, the p value and q value. So here I am going to explain how to access this one, p value and q value.
Yes, all of you look at this one. Now I am going to take the p value and q value. So for example, now I assign the p value. P is one of the prime, and q value we have to take another one prime. P value 3 I have take, then q value 11. How do you find out the product of the prime numbers? See here, n, p, q. So you identify, yes, now we have to identify the values from the product of the two numbers. So first p is 3, 11 threes are 33. So this is a n value. Okay. So p value, q value given, the p and q are the product of the prime numbers. Next we have to calculate pi of n. Pi of n is a Euler torsion function. How do we calculate? P minus 1, already we know the p value, and q minus 1. So p value is, already we know that p value is what? 3, 3 minus 1, then q value already we know 11, 11 minus 1. 3 minus 1, 2, then 11 minus 1, 10. Now pi of n value is 20. This 20 value we find for the Euler torsion function. So using them we need to identify the d value. So e value is directly we can assign, e value is a 7. Next we need to identify the d. So formula is there, 1 plus then pi of n k divided by e. This is a formula for finding the d value. So 1, then pi of n value already we know 20. Then k value we need to assign, start with the 1, 2 until when you find the integer value, that is called rounded value. So up to that we have to calculate that value to be increased. Here the first k value assign 1, then e value already we know, e value 7. So here 1 plus 27, then 21, 7. So when we divide, we have got the result. So d value is 3. So the 3 now assigned. So after you find the d value, next we have to apply the formula. So what the formula is given is, next I have to move to the slide. Yes, look at this one. Now we got the 3, but here not given how to identify the d. So however, we need to understand the d is a multiplicative inverse, the e of 7. So d value we find out. Next we have public key. The public key how do we generate, and private key also we finally we come to that part. The n value, n e value 33 7 and private key value 33 3. Next we have to go. So sharing the public key. How you share the public key? So public key and private key is here. We want to share the public key. So public key is shared with the center. So why we need to share with the center? Because using the public key only we can able to decrypt the message. Okay, and that private key is kept secret with the receiver. So using them, finally the receiver can able to decrypt the information. So first we need to encrypt and decrypt the message. So here one more example. Yes, that encryption message here. So center I chosen one message AAC, the numeric conversion.
So A is Z, that A is Z starting with 1 to 26. A value start with 1 and end with Z value 26. So here that A value AC now encrypted 13, the numeric representation of AC. So next we have to go. Encryption formula is already we know that the 13 power A, already we know the value of M. M is the 13. A few minutes back the AC values converted as ASCII, 13, 13 power 7. So mod value, finally the C value calculated 7. Now after you find out the C value, next we have to decrypt. Decrypt message. M ciphertext already we know that 7, 7 power 3. So 343. When we take the mod 33, finally we got the 13. First we encrypted 13 is right. Now after decrypt, now we finally got the result. So this is a process actually. So next we have to go. We have to go for. Yes, this is a very important one. But we are now using the RSA algorithm. We are confident as a working on RSA algorithm. But quantum computing can break the RSA algorithm. So if the break the system means what should I do? So now research is going on. We have to generate that RSA algorithm based this algorithm we need to enhance. You know the quantum computers could effectively factor the large numbers because of the quantum computing means it is processing the million datas and trillion datas within a second. So that's why this is not a safest one. However, we need to enhance that RSA algorithm security. What are the way we have to enhance? Use strong keys and protect private keys and implement side channel attack mitigations. Using this technique, we can avoid the leakages and stay informed. Okay, so these are the procedures. Using them, we can enhance the security of RSA algorithm. So one more thing we should understand in this current research, if I use the quantum computing system, is easily breakable the any largest numbers. That means any numbers I can be factorized. So however, our research in this system, the quantum resist cryptography algorithm. If I have a quantum cryptography algorithm, so your RSA algorithm is more secure. You feel more comfortable. So using them, we can do the multiple process. So these are the way we can identify. So next one, we need to understand that applications of the RSA. So wherever the RSA algorithm use, what purpose RSA algorithm? So for the secure transmission, though it means what? So encrypting the data for confidentiality. It means what? The securely you can store the information. So don't expose to others. So this is called that confidentiality. Next, key exchange. Key exchange, establishing the shared the keys. Last one, the digital signature. So this digital signature, the verifying the authentication and the integrity of the messages. So this is a process actually. So as far as we have discussed RSA algorithm. So these are the system. If understand that RSA algorithm, we can make the multiple messages with a secure manner. So these are the system we need to understand. When we introduce the quantum computing can be breakable any largest system. However, the solution given. So cryptography, the quantum computing based on algorithms generating. This is our online research. Thank you.